Hi, and welcome back to the second part of my video series on data types in R, which are six, like we established in the first part of the video: the vectors, list, arrays, matrices, factors, and data frames. So we have dealt in a bit with on vectors, types, and the classes of vectors. We've dealt with lists. We have talked about arrays, and so let's talk about matrix. And why exactly do I actually leave matrix for the second part? This is because matrix is so important, just like I have been stressing the importance of vectors since. And if you look at it very well, you will see combination of two vectors would give us a matrix with two dimensions in terms of the row and the column. So if you look at most machine learning algorithms, they rely heavily on the concept of matrix algebra. So that is why during the training and the predicting phase in most of these algorithms, they perform some forms of matrix algebra, be it regression, be it neural networks, be it time series, be it classification, be it support vector machines. They rely heavily on the concept of matrix algebra. So it is important we have this understanding. So when we run some of these codes, we would understand exactly what is going on, and this in return will boost our confidence about these machine learning algorithms. So what is a matrix? A matrix is a two-dimensional rectangular data set. So it can be created using the vector input to the matrix function. So a matrix is created using the matrix function. Just very simple. So you do it this way. You say matrix in small letter. This M is in small letter. And then you put the data, which is a vector input. You specify the number of row, you specify the number of column, and you specify this argument by row and the dimension name. So over here, I just explained what each of those arguments stands for. So the data is the vector input, the n row, the number of rows to be created, the number of columns to be created. Sorry, this is a mistake, not rows, it's ROW. So the by row is a logical value, not Q. If true, then the input vector in the elements are arranged by row. If false, otherwise, it will be arranged by column. So we have the dimension names, which is the name assigned to the rows and the columns. So let's just have a simple example. We are creating a variable called VTR using the less than assignment operator, combining the elements we have in that variable with the vector function. We create another variable again called VTR1. The same thing, we are combining the elements 4, 5, 6 together into it, and then we are using the combination of these two variables to form a matrix and then store the result in a variable called MTR. So this is it. We are saying matrix, and then we say C VTR, VTR1. So what this is going to give us in essence is going to give us the combination of 1, 2, 3, 4, 5, 6. That's what we are using in creating that particular vector. And then this particular argument stands for the 3, stands for the row, the next 3 stands for the column. So this means we are creating a square matrix, a matrix that has a row of 3 and a column of 3. So if I run MTR, you will have the result in this particular form. So note, when you are creating a different dimension from the above, make sure the number in your rows and columns are a multiple or sub-multiple of the element present in your vectors. This is an example of what I'm saying, and we'll still see it during the practical section clearly. So we have MTR, the same code above, but I'm just changing the last 3 for the column and I'm giving it 5. So this will display an error as 5 is not a multiple of the element present in the vector. Same with 7, 11, and 13. It works majorly for prime numbers that has just two factors, itself and 1. So before I move away from this concept of matrix, like I have said, they are very essential, especially if we want to gain full understanding of some machine learning algorithms. We would need to understand the basics. What is scalar? What is the meaning of the word scalar? What do we mean by vector? What do we mean by tensor? How do we perform some basic matrix algebra? How do we add matrices together? Do some subtraction, division, find the determinant of a matrix, take the transpose of a matrix. All these are crucial. They are very important if we really want to understand some things well in the field of data science. So the last, or not the last, the second to the last that we'll talk about is factors. So here I said factors are the data objects which are used to categorize the data and store it as levels. Take your mind back to the video on variables. I said we have two types of variables, numeric and categorical. Numeric, discrete or continuous. Categorical are of two types, either nominal or ordinal. And now there was something I said to deal with categorical variables in R, we use the factor function, and that is where we are now. So they can store both string and integer. The labels are always character, irrespective of whether it is numeric or character or boolean, etc. in the input vector. So the labels are always character. So they are useful in data analysis for statistical modeling. So they are very, very crucial. They are very useful, and we'll see it when we get to that to the practical section. So factors are created using the factor function. I have said that earlier, and the n levels function gives the count of the levels. Let's see an example. We have a variable called apple, and we're using the less than assignment operator to combine all the values, the character that we have to store in the variable called apple. So we have green, green, yellow, red, red, green, and then we are saying that is just a vector. And now we want to create a new variable where we would be using the vector as an input to the factor data types. And that's what we are doing here, where we have FAPU. And then if I print FAPU, this is what's going to happen. We're going to have green, green, yellow, red, red, green. And then you would have something like levels underneath, green, red, and yellow. So this level is just talking about the unique value we have in that FAPU, which is a factor object. The unique levels we have, the unique levels are just 3, green, red, and yellow. So if I want to see it, if I want to have like a numeric count of it, I can use this function, print number of levels of FAPU, and it tells me the number of levels are just 3. So this is just the basic understanding I will provide in this second part that deals with the theory behind each of these data types before we move into the full section of practical. So the last would just be on data frame. So when you hear data frame in R, what should come to your mind is how to create table, like your typical Excel table. How do I create it in R? So we use the data frame function. So unlike a matrix, in data frame, each column can contain different modes of data, which is not the same in matrix. Matrix will have everything in character. The same thing with vector. Now the first column can be numeric, while the second column can be character, and the third can be logical, etc. And ensure that they must be of equal length. Though, even if they are not of equal length, there are functions that we can even use when we have such a situation. But ensure in this case, let them be of different length for us to understand it from the basics. So data frames are created using the data.frame function. So for those of us using RStudio, it's very easy. the concept of IntelliSense in RCD. So if you just press data dot, it will bring out this for you as a suggestion. So let's see an example. I am creating a variable and I'm saying I just want to combine numbers from 1 to 5 and store it in a variable called SN, like the serial number. And then I'm creating the gender of these 5 people. And then I'm using the vector function again because they are more than one, and I'm combining them together into that variable. We have male, male, female, male, female. Now this is st underscore names, and then I'm saying we have the names of these students in my class. The first is with my name Josh, the names is with James. You could see they are all quoted. The next is Chirac, the next is Sam, and the last is Johnson. And then we have their age as a new variable, and then we combine it again using a vector function 24, 22, 20, 28, and 21. The last now is the data frame object. So we are saying the result we are going to get when we want to turn everything into a table, we are storing it in a variable called tab. So I'm going to say data.frame. Now we want to create a table with all these vector inputs we have created in the first place. So we say data.frame, open bracket, and then you begin to impute the variable as the argument in that particular function. So we say serial number, the gender, student underscore names, and we put the age. So if you run tab, this is exactly what you're going to have. So you're going to have serial number 1, 2, 3, 4, 5, just like a table on Excel. So at this junction, I would want to say a big thank you for your time, and for those that are joining us for the first time, I would plead with you to subscribe to the channel to see the next video, which is going to be more on the practical, where we would talk extensively on the real-time application of these data types. And for those that are yet to turn on the notification bell, you can do that. And I want to say a big thank you once again. Thank you for choosing to learn R with me. God bless you. Have a great day. Bye bye.